Today we are going to learn why do you need HTTPS. I'm going to start with a live demo. Here I have a little Express API that runs on two ports, for HTTP on port 3000 and for HTTPS on port 3001. The endpoint is very simple. It's a get request for this endpoint, and it gets somebody, sets 200 and responds. Let's make a call to both of those endpoints so you can see that I'm going to get exactly the same thing back. So you can see this is my IP, my local network IP. This is 3001 HTTPS. So I get some response 200 with the body of a secret. If I do the same for HTTP request, same IP, just different port, same endpoint, I'm guessing exactly the same. So if you get the same result, why do you need to bother with HTTPS? There is a reason. Let's have a look at the actual network request that we just sent and try to spot something interesting here. What I'm looking at is a proxy that I configured my Postman to send all requests through this proxy. So this little program captures all traffic that goes through it. So I can see that there was a request to HTTPS endpoint 3001 port, and let's try to figure out something out of the request. It doesn't look very helpful. The only thing that is familiar to me is this thing, which is my local IP. So that's the only thing that I could see. Other stuff is encrypted. Same if I look at the response, there is like nothing really useful in the response. Now, if I look at the HTTP request, I can see everything in the what was the request, what endpoint did we hit, some headers, and I can see the actual plain text body of the, it's better like this, of the response. This is an example of how your passwords or sensitive information could be stolen by a hacker, because even this information, for example, which exact URL you are hitting, could be violating your privacy. I'm not even talking about the response or request headers that could be very like having your passwords or usernames or some data that you really don't want to share. Let's compare this request once again. Nothing except the destination IP, nothing in the response, everything in the response, everything in the request. Now we know how a HTTPS works from the external observer, which is this program, perspective. Let's now talk about how it's actually happening. Right now, it looks like a miracle. Something happened and all these things are encrypted. But how this is happening in real life? Note that what I'm going to show you is going to be a very simplified version that resembles the process that happens in real life. It's not exactly like that. I do that just to explain it in a very simple manner. So imagine we have a client, also known as your computer, and a server, also known as, let's say, backend API running somewhere. We want to be able to securely talk between those two without hackers intercepting our secrets. So I'm going to draw these lines. So this is the public space, right? Everything that goes here could be visible by hackers.
Very happy
so when
to
the
see
client
it.
sends something to the server, this area is absolutely visible to everyone. So as a step number one, the client will make a key and a little box. I'm going to explain what this box is for just in a second. So there is a little box, which is open box. It has a very remarkable property. Once you close this lid of this box, the only key that could open it is this key. But right now, box is open and box is absolutely empty. The client will take this box and send it to the server saying, wanna talk? Also, the client gonna send an empty red open box with it. I can see something. It's the red box. Reminder that the only key that could open this box after it's closed is this key. This box has no secret information in it. If the hacker makes a sneak peek, or if the delivery person looks at it, it's fine. Now imagine server decides that, yeah, this box looks good and I'm ready to talk to the client who have sent me this box. What server gonna do is it's going to generate its own box and the key. I'm gonna draw a little green box. So something like that. Now the server has its own box and the server has its own green key. So the only key that could open this box once it's closed, it's this key. But it's not all. Server also needs another set of keys and the boxes. So I'm just gonna do a little blue one. So something like that. I'm gonna explain why you need it very soon. So what server is gonna do next is it's going to take those two, put them into the red box and close the lid. I'm gonna draw like this. So red box now closed. This blue box and the blue key is inside. Also server adds open green box. So roughly it's gonna look like this. Yes, I'm ready to talk, and here's your locked red box with something secret inside. In this public zone, remember, everyone can look on the traffic or boxes that traveling around. So if the hacker or a post person looks into this box, they're like, well, it's a box, it's locked, I cannot unlock it, I cannot see the content at all. The only key that could open this is this one. And the green box is empty, open box. There is nothing secret about it. What does the client do now? Well, the client can now use their key to open this locked box and get the copy of the blue box and the key that is stored in their private area. Remember that this line was separating between public area and the private area. This zone is private for the client. This zone is private for the server, and this zone is public for everyone. Now, the client needs to acknowledge that they got the right content from the server and that it's actually the right client that got it. So the client will basically say something like, hey server, this is what I got from you, and I'm gonna put a copy of it into the green box and lock it. So what it means is that client certifies that they got the red box without any kind of damage. They were able to open it with their key, which is here, and they extracted this content. And also they want to be sure that this green box came from the server they want to talk. So they want only the server to open this box with their own key. So they acknowledge, yeah, we got it. Can you actually open this box? And so I'm sure you are you. From here, it becomes pretty simple. The server can generate a secret. Both server and the client have the copy of the blue box and copy of the blue key. So what server could do is server could put a secret into the blue box, locks the lid. So secret now is inside, and this is being sent to the client. Client has a key, can unlock this secret, and can say, got it, and reply back in the same locked blue box. And the server has a key, so the server can unlock it again on their side. Let's look at the whole diagram again. You see that this process of sending boxes there and back was quite complicated. There was a lot of moving things involved. But after the exchange of the blue box and the blue key happened, everything becomes super simple. You just put something in the box, close the lid, send it, the server can open it and reply in the same way. Put the reply into the box, close the lid, send it to you, you can open it. Very simple. I want to emphasize once again, this is just a simplified model of reality. I use this box analogy to just demonstrate how the encryption works. In real life, it's slightly more complex, and you shouldn't trust everything I told you here. But what you should do is you should go and read more about different, let's say, encryption algorithms or key exchange algorithms like RSA or Diffie Hellman, and learn a little bit more about how this actually works, because it's pretty fascinating. And now you understand basics of HTTPS. Reminder to check out my other videos. That's gonna appear all over the show. And see you next week. I didn't get to steal any data.